Deep beneath our feet, in the vast networks of pipes that bring us energy, there's an invisible war being fought every single second. Seriously. It's a battle of chemistry, and it's the only thing keeping our world powered up.
Getting energy from the ground is way more than just drilling a hole. It's a nonstop chemical fight against all kinds of problems. And the heroes of this story, the invisible army fighting this war, are a specialized group of compounds we call production chemicals. All right, so let's tackle that first big challenge, that messy mix of oil and water that comes straight out of the well.
This stuff, it's called an emulsion. And the best way to picture it is like a really stubborn salad dressing that just refuses to separate back into oil and vinegar. And when it's in this state, crude oil is pretty much useless. You have to break that bond before you can do anything with it.
So how in the world do you fix it? You call in a specialist. And in this case, the specialist is a chemical called a demulsifier. Its entire job is basically to be a professional relationship breaker for oil and water molecules. And the way it works is actually pretty elegant. The demulsifier zips right to the boundary where the oil and water meet. It then weakens the film that's holding them together, and that lets all the tiny droplets of water find each other, clump up, and separate out from the oil. And just like that, problem solved. Okay, but separating liquids, that's just battle number one. The next challenge is all about the plumbing itself. What happens when the industrial arteries of an oil field start to get clogged up? And that's not just a clever metaphor, it's literally what happens. Over time, solids can build up inside the pipes. We're talking minerals, waxes, all sorts of gunk. It restricts the flow, and if you don't deal with it, it can cause a complete blockage. It's basically the industrial equivalent of a heart attack.
Now get this, not all clogs are created equal. You've got hard mineral scale, you've got soft waxy paraffins, tar-like asphaltanes, and you even have these weird ice-like things called gas hydrates. And because they're all so different chemically, each one needs its own very specific chemical inhibitor. It's like needing a unique key to unlock each specific type of blockage to keep the oil moving.
Okay, so we've separated the fluids and we've kept the pipes clear. But there's another enemy lurking, one that attacks the very bones of the operation. We're talking about corrosion. You have to remember that crude oil mixture is a really aggressive place to be. You've got water, you've got corrosive gases like hydrogen sulfide or H2S, and you even have living bacteria. And all of them are constantly trying to rust, dissolve, and literally chew through the metal pipes from the inside. So what's the fix? Well, you call in another chemical hero, a corrosion inhibitor. Honestly, the best way to think about it is like sunscreen for steel. It creates this invisible barrier that shields the metal from all the harsh things trying to attack it. And how it works is, honestly, simple but totally brilliant. The inhibitor molecules are drawn to the metal, where they basically link arms and form this super thin but really durable protective film. And that shield physically stops the corrosive stuff from ever even touching the steel. So, as you're probably realizing, this isn't about just dumping one random chemical into a pipe. It's about managing a really complex and precise chemical cocktail that's custom-tailored for every single oil field out there. And let me tell you, this takes some serious expertise. People like Zer spend their whole careers mastering this. It's a wild combination of chemistry, engineering, and almost detective work to figure out what's going wrong and how to fix these invisible problems. This chart really breaks it down for us. You can basically group all these chemicals into three main missions. First, you've got flow assurance. That's all about keeping those arteries clear. Then there's separation, for breaking up those emulsions. And finally, asset integrity, which is about protecting the equipment with things like corrosion inhibitors and biocides, which kill off harmful bacteria. And believe me, the toolkit is even bigger than that. You've got anti-foams to stop the oil from getting too bubbly, drag reducers that actually help it flow faster, and things called scavengers that act like little Pac-Man, just gobbling up harmful molecules like H2S and oxygen before they can cause any damage. So, after all that, why does this hidden chemistry matter so much? All right, let's bring it all home and connect it to the energy we're using every single day. Look, at the end of the day, this isn't some abstract science experiment. The gasoline in your car, the electricity that keeps your lights on, it all depends on this invisible army of chemicals winning their little battles 24 hours a day, 7 days a week. But this science is not standing still, not by a long shot. the whole field is constantly pushing forward. People are doing serious research into green chemicals that are way more environmentally friendly, and even exploring the frontiers of nanochemicals that could solve these old problems in brand new, super efficient ways.
Which really just leaves us with one final thought. The complex chemistry we have today powers our entire world. But as we look to the future, the real question is, what incredible new chemical solutions are we going to have to invent to power the world of tomorrow?